To allow users from other chains to play our RPS game, that means using our RPS module, we'll have to implement an IBC middleware for our module. What this means is explained on this graph. You will have this. This is how the architecture of IBC and in an application looks like, and what the IBC middlewares are. So you have a core IBC here that we already implemented in our chain, and we have our base application. You can define many middlewares, either stateless or stateful middlewares, even that we perform many manipulation of incoming and outgoing messages. As you can see in this figure, you can have one message that's getting into the application, an incoming message, and you have a middleware too that will pick up this message, perform some manipulation. Then we'll have a middleware one that's going to perform another manipulation on top of whatever the previous middleware did, and get into the base application with both of the changes applied. The same with outgoing messages. We'll start with a message M, and the outgoing message is going to pass through the middleware 1 and then through the middleware 2 to the core IBC and then outwards from the application. So we are going to create an IBC middleware for our RPS module where an incoming message is going to have a memo field that's a string, and we are going to parse this memo string, and if it has a message that corresponds to one of the messages that we will define in the middleware, it will perform an action on our module and change the state of the application based on that. So let's start working on this. In every IBC packet, there's a memo field that it's a string. If you check in our RPSD chain, the transaction IBC transfer, the command transfer, we can say get here a help, and you will see that here we have a flag that's called memo string. It's a memo to be sent along with the packet, and this memo string is the one that we are going to use to know if a player wants to play a game in the RPS module or not. So let's start creating some types in our RPS module. Within the types, we will create a new file called ibc.go. This is package types. We are going to have here some valid transaction types that we'll look for in the memo of the packet. So we'll have a create game, a make move, a reveal, and then we'll define here a packet memo type that we are going to call RPS. That's a transaction with JSON tag RPS, and the type transaction is going to be your type string, the type with the JSON tag type, and the message, which is an interface JSON message. So let's write some note here. IBC packet memo can trigger a transaction on DX RPS module. we expect the memo to be a JSON object with a field RPS. The value should have the fields of a valid message. This means the create game, make move, or reveal move. Message create game, message make move, or message reveal. So basically what we are seeing here is that in the memo field of a packet, we'll look for a JSON object that's going to have the RPS, and then we'll have here an object that's going to be the type of what the transaction wants to perform this user. If, for example, if it is a create game, and then the message itself, the fields for the message, that will be, for example, opponent, the creator, and we'll have some address here, the opponent, also another address, and the rounds. So if we find something like this in the memo, we're going to parse it and we're going to get the corresponding message and execute it. So that's what we're going to do with these types. So let's create a function to parse this memo. This is going to parse into an interface that's going to be the message and the error. Parse the memo if contains a valid message. JSON Marshall RPS message. And then we're going to have a message that's going to be an interface. And based on the defined type, PM RPS type, we're going to set the message to that particular interface. Reveal. And default will return an error. It's an invalid transaction type. Got whatever you sent. PM RPS type. And then we're going to Marshall and Marshall the bytes into the message. If there's an error, return nil or error. Otherwise, we'll return the message that we're going to execute in the module, and that's it. Another thing that we want to do, it's like we previously had a validation for the create game for the address of the players to be an RPS address. So we'll have to convert the incoming address. For example, if we try to create a game from another chain like Evmos, the signer is going to be an address with the Evmos prefix, so we have to convert that to a local account with the RPS prefix. So we can do that with a helper function that we're going to call getLocalAccount to an address on the RPS chain. Function getLocalAccount We'll return an account address, an error. So here first we'll get the bec32 prefix from the address string. So we're going to string split and the address. We're going to split it by the 2 pieces. This is because in every address you will see that if you do keys list, you will see that all addresses has the prefix, that's RPS in our case, and then a 1. And this happens in all other Cosmos chains that are using this bec32 prefix. So we are splitting by this one, by the first one that we find. So then we can get the address bytes from the split string. So we are going to split it by this one, and we only want to get the corresponding bytes of the address. Get from bec32. We can get the address and the bec32 prefix. And if there's an error, we'll return nil and the error. And then we'll verify the address from the address bytes. If there's an error, we'll return it. And then once we have the address bytes, we can just add our bec32 prefix using the account address, the address bytes, and we'll return an account address within our chain. We can make some tests for this. Pause the video and write some tests. I'm going to write them and then show it to you. Here I added the IBC test.go file within our tabs where we test the functions that we defined in the IBC Go. So you'll see here a test for parsing the packet memo. I added a couple for the create game. If you want, you can add more with the different messages if you haven't already, but making sure that we are passing this JSON within a string and should be parsed into a message create game. This is a post check function. You will see I have a parse check, so I just run the function for the test case here in parse and then check for the message. And the same for the local address. I added some valid addresses from the Cosmos Hub, Osmosis, and some invalid address, and check the expected local address, or if there's an error expected, we can check that all these are passing. This is passing, and this one is passing as well. So we have these functions working. Now we have to go and start working on our IBC middleware. An IBC middleware can use any of the callbacks within the IBC message lifecycle. If you go here in the documentation to the create a custom IBC middleware, you will find in this page how to implement the IBC module interface needed for your middleware and all the callbacks that you can use. As you can see here, you can use a callback when trying to open a channel. You have also when the next stage that it's the open channel try. Then we have the open channel acknowledgement. You can change any of these. You can add a custom behavior on any of these callbacks, but the one that we only care about at this moment is this one on receiving packet. This one is going to be called when receiving a packet from another chain, so we'll have to implement only this callback in our case. But if you, for example, want to implement some logic when sending some packages. You'll also have some send packet callback that you can use and write acknowledgement as well. So yeah, here you'll find all the documentation that you need, but for us, just the onReceive packet will do. So let's add this callback to our RPS module. So we're going to go here in our PS keeper. The keeper is going to have a new file that we're going to call IBC callbacks. We're going to define our custom logic for the callbacks. This is going to be package keeper. And we're going to have here a function from the keeper that's called onReceive packet. That's going to have an SDK context, a packet of channel types. This is the IBC packet, and an acknowledgement. And we are going to return an acknowledgement as well. Let's add these imports. Acknowledgement. You see here in the packet we have all the information. What's the sequence of the packet, the number that corresponds to the order of sends and receives from the connection. Then we have the source port, the source channel, the destination port and destination channel. The data, this is where our IBC transfer is going to have all the information. And then we have a timeout and a timeout timestamp, a timeout height and a timeout timestamp. After these timeouts, if the packet was not relayed and acknowledged, it will fail and revert any state change on the origin of the origin chain. So let's write our custom logic here. So the data in the packet is going to be IBC. This is the type of data that we are expecting. That's just transferring funds, and as you can see, we have a denomination, an amount, the sender, the receiver, and the memo. This is the memo field that we are going to use. So let's parse the data of the packet. Must and Marshall JSON. In our case, we only enable this functionality for IBC, so we should always be able to parse the data into the fungible token packet data. So now we'll check for the memo field. If it is not parsed successfully, it's okay. We'll do no operation. It will be a normal token transfer via IBC. So let's do packet memo. Is going to be of our types packet memo, the one that we just defined previously, and we're going to parse this into our packet memo. If there's an error, it's okay. There's no information that we want to get from this memo, so we'll return an acknowledgement and everything will continue. It's not an expression. Packet memo. And Marshall. Then we can parse the message, the memo into a message. We'll see if there's an error. Again, no problem. Everything continues without any issue, just as a normal IBC transfer. But then if the memo contains a valid message, we'll have to parse the local address of the packet sender. So we'll have to get the local address for the packet sender. to use as the player that creates or makes a move. So here we'll say player account types get local account from the data sender. This is the sender from another chain. So we'll parse it to our local address. If there's an error because it's an incorrect or we couldn't parse it, ignore the memo and just perform a normal IBC transfer. And then we'll get an instance of the message server to send our message to the module. And here we'll have this switch for the different types, RPS type. So if we have a create game, we'll have to call the create game function. So we'll have to parse this message into the types message create game, and we'll update the creator to be the player account. This is the local account, and the opponent is going to be here. You can choose to do two things, or either leave the message as it is, or the opponent be the receiver of the transfer. Just to be for fun, we're going to set here the receiver. So the opponent is going to be the receiver of the transfer. And then we're going to call the message server create game with the create message. And we'll do the same thing for the two other cases. We update the player, but then it's the same message, and the default, if it is not within any of the transactions, we'll return the acknowledgement and perform no operations here. And then if there's an error within this parsing and sending to the message server, we'll return an error in this case because it was not a successful transaction, and we'll create a new error acknowledgement, and this will revert the whole IBC transaction. Otherwise, we'll return the acknowledgement that everything went okay, and that's pretty much it, the logic in the IBC callback. Now we have to wire up to be this an IBC middleware and into our application. So let's do that. So within our RPS module, we'll have to add a new file here in the root of our module, IBC middleware.go. It's going to be package RPS. And here we'll have to comply with an interface. That's going to be our IBC middleware type struct that has port types, IBC module, and a keeper of type keeper port types. So this IBC middleware implements the ICS20 callbacks. That's the callbacks that we saw previously, and ICS4 wrapper for the RPS middleware given the RPS keeper and the underlying application. So now create a new IBC middleware to instantiate on the underlying application. So we'll have a new IBC middleware. App is going to be port types, IBC module. In case it's going to be keeper, and it's going to return an IBC middleware. Return IBC middleware. And the keeper. And then we'll have here to define the corresponding callback for our middleware that we already did. So we'll have IBC middleware on receive packet account address. And this is going to return an IBC exported acknowledgement, the same as our callback. This is the same. And we also can get from here the SDK types. And the acknowledgement is going to be the IBC middleware, IBC module, and the relayer. This is the base IBC middleware. And then we'll return here if there's already an error in the acknowledgement. If the acknowledgement is an error acknowledgement, so if it's not success, there's nothing that we're going to do with this. It's just a basic acknowledgement fails. We don't want to do anything with that. And then if everything looks good, we'll perform our custom logic. That's going to be keeper on receive packet and acknowledgement. So here we are wiring up our custom logic that we just defined in our IBC callbacks. If you have different callbacks, you will have to implement the same for each of these callbacks for your IBC middleware. And then the last step is to wire this up in the application, in the transfer stack. If you remember, we defined a transfer stack in the application.go. Let's go to app.go, where we have the transfer stack. So here we'll have to wrap this with our RPS new IBC middleware, IBC transfer. We'll have this plus our keeper. And this function that returns the IBC module is going to be input for our new IBC middleware, and this way we're wrapping within the transfer stack our custom logic for our IBC router, which you are setting it. So that's pretty much it. Now it's time to test this.